Our sea level is rising and will continue to rise this century at an increasing rate, causing a higher flood risk all over the world.
The biggest challenge is to keep 80% of the world population safe and prosperous.
Sea level rise and climate change makes that storms are more severe, the water levels are higher.
So dunes, dikes and storm surge barriers need to be evaluated and designed to take the sea level rise into account.
And to do that in a cheap and effective fashion, I think that is the biggest challenge.
To meet the challenges of the sea, researchers of the Dutch Institute for Water Research, Deltares, wanted to create the highest artificial waves in the world. So they built a flume, the Delta Flume.
We needed a facility to do large-scale research, especially on those topics which cannot be scaled down into a small-scale facility.
We need to build these structures, dikes and dunes, as large as possible. If you build them small, you get less reliable results.
Then you need a lot of knowledge that we can gain from our Delta Flume experiments.
As an ecologist, I'm interested not only in studying dikes to protect us against flooding, but in using nature to do that. And in this design, we have the space and the conditions to include nature in our research.
The true power of the Delta Flume lies in its dimensions: 300 meters long, 5 meters wide, and 9.5 meters deep. And in its huge waveboard.
That waveboard is pushed forward and backward, and so it creates those waves. And those forces in which it moves that board are tremendous. It can move a block of brick houses, 5 in a row. It can push them aside, just like that.
Containing 9 million liters of water, the Delta Flume can create artificial waves as high as 4.5 meters. Higher than anywhere in the world.
Those high artificial waves are necessary because along the Dutch coast we have those high waves during extreme conditions.
With these high waves we can simulate real storms, so we can test the dike in real storm conditions.
The Delta Flume is so special. We can look in more depth and more detail than anywhere else on the world into extreme events. In that sense, it's like the Hubble Space Telescope for water research here on our Delft campus.
The Delta Flume is a testing ground for full-scale water defences, and it allows for a large variety of research.
The test we are doing here is about the stability of the block revetment under wave load. We are doing tests with different wave heights, and we start at a rather small wave height and then we are going up.
We also want to know what is the strength once the outer slope fails. So how long does it take before the dike actually breaches?
How fast will that go? And do we have any opportunity to move away people? We can also do tests on bottom protection at pipelines, dune erosion.
But it can also be more detailed research, like what are the flow velocities, what is the wave overtopping and that kind of thing.
You can also do innovative solutions, like putting a forest in front of the dike.
We can experiment with real trees under these real extreme conditions. And we do not know yet how this is going to work, so we need to use this flume to do that kind of studies.
You can only do that kind of research on a very large scale. If you do that on a small scale, your results are not reliable.
The Delta Flume is unique, as it is the most realistic and most advanced wave research facility in the world.
The Delta Flume is something we are very proud of.
I can do research here at full scale, and that makes that the research results are very accurate.
Well, we need to evaluate our dikes every 6, 12 years. So using the knowledge that we have on sea level rise, we can take that into account when we design or improve the existing dikes.
The knowledge that we gain here makes the world a little bit more safe.
This flume will help us face the future challenges of the sea to reduce risks and costs. And most importantly, it will help us save lives.